Counting. The very first thing we're introduced to when we are learning mathematics, it's counting. I want to show you how exponents are related to counting, a different way of looking at it. So here, for example, I have 1, 2, 3, 4, 5, 6, 7, right? And we've come up with symbols that mark how many things we have. 1, 2, 3, 4, 5, 6, 7. And so we have 7 balls in this case. Okay, fantastic. Exponents can also be thought of a way of counting. But before I do that, let me show you another. Sometimes we count by grouping. So, for example, this method here of counting allows us to count by grouping things. So, for example, here I've grouped everything in fives. So multiplication allows me to count, but faster than this type of counting. 1, 2, 3, 4, 5, 6, 7. So here I can describe this as 3 times 5. That's 15, and that is also a form of counting, but faster way of counting. I could even take this a step further. If I wanted to count how many boxes I have enclosed here in this rectangle, I can do the following. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, and I could gonna use multiplication to find how many boxes, squares are enclosed there. 8 times 3 is 24. So again, I've used a different way of counting without literally going back to our basics, which is count 1, 2, 3, 4, 5, 6, 7. Notice here I group by fives, and I have 3 groups of 5, so again I go 3 times 5 is 15. Alright, let's take this a step further. I've enclosed again another set of squares, but this time I've done something a little different. I've enclosed it, so in this case this height is 3 and this width is 3. So if I wanted to count, this would be 3 squared, and this would give me 9. If I want to take this further, suppose I did the following. I created a 3-dimensional. Now I've created a cube, and this cube is 3, 3 by 3. So if I wanted to now find how many cubes are on here, what I would do is multiply 3 times 3 times 3, or 3 cubed, and that would give me 27. And now I know I have 27 cubes in there. Again, a form of counting. But notice in these two instances, 2 and 3, what I'm doing is I'm creating groups of 3. Now, let me do another thing. You're not going to like this. It's a little bit unpleasant to look at, but I'm going to use the same system I used here a minute ago with these 5s. We'll come back to this. So let me do the same thing with the 5s. So originally it started with a group of 5 here. And if I counted it, this is one group of 5. Or if I use exponential notation, 5 raised to the first power. Now, this is all about group. So how do I find how many are here? Well, I have my first group of 5, and then I've taken that and replicated it another 5 times. So what I have is one group of 5 times 5 groups of 5 for a total of 25. Now, what if I wanted to do this again? What would 5 to the third power? Notice this is 5 squared. Well, hang on for a second. Here we are. So what have I done? I started with a group of 5. Then I created another set of 5 using that as my template. Now this becomes my new template, this entire row, and then I replicated this 5 more times. So if I wanted to know how many things were on here, I notice that I have my first group of 5, then I replicated that 5 more times, then I took this set and replicated it 5 more times. So in other words, what I have is 5 cubed, or 125. So notice this is a form of counting, but in a very, very different manner. Every single time I'm doing the following. My first number marks how many things are in my first set. Then the second number says how many times I replicated this, in this case 5 times. The next number says how many times I replicated now these two things. So the number that keeps following this one says I'm taking what I had previously and creating 5 more of them. So the next 5 would be 5 of whatever this comes out. So in other words, this set now that you see right here, imagine now 5 versions of that. So this would be 5 to the 4th. So you see, this is sort of a way of counting, but counting in a very, very different manner by grouping and then increasing that grouping. So at this moment, you're going, wait a minute, what's going on here? I mean, gosh, my brain is a little bit confused. That's okay. The confusion is arising from the fact that this is not a process you encounter every day. So of course it looks strange. If you just played around with this idea, I would guess that in a very short time you would come to accept that that's a way to view another type of counting. And the reason this is important is because logs are viewed this way. Logs are all about the exponent. So right now, notice this exponent just tells you how many times I've engaged in this process, altering my original set by a factor of 5. Now, at first you might say, this is totally foreign. I've never seen this before in my life, and I probably never will. Well, guess what? You have seen this before, and you're using it all the time. So our numbering system is Hindu Arabic, and it's based on a very ingenious idea. If I write the number 231, what is the number 231? Well, all I've done is I have these place values. The first one is based on 10, 10 to the 0th power, and what can go on here is as the digits 0, 1, 2, all the way up to 9. The next set is 10 to the first. The second is 10 to the, the third is 10 to the second, and so on. So you'll notice I'm increasing by powers of 10. In other words, this is my first set. This one is now going to be 10 times this one. This one is going to be 10 times the previous, which is 2 put together, and so on. So the next one is always counting on the ones prior to it. But you're saying, wait a minute, I don't even see that. How does that work? Let me go back to another viewpoint. When I wrote this right here, 3 times 5 is 15, you'll notice I hadn't quite reached another set of 5. In other words, I hadn't replicated this 5 times. I've only replicated 3 times. So I go 3 times 15. When we use our numbering system, it's the same concept, but is based on tens. So for example, if I want to add 9 plus 1, what happens? Well, this is 10 to the 0th power. Sorry, I'm putting the value, 10 to the 0th power. And what happens is, when I add this to this, I move up. This can only hold the digits 9 to 1, and then once I have my set, I make my mark. So this is just like a mark, saying I have now one full set of the previous thing, and then I put a 0 here. So in a way, that's what we're doing when I write something like 23. I'm just saying, look, I have 2 of this thing called 10 to the first, plus another 3 of this thing called 10 to the 0th power. But it really is the same thing. Exponents happen when I have a full set. So once I reach a full set, I'll just mark it with my little exponent. So I have now 3 sets based on 10. So I started with one set of 10, then I created another set, replicated those 10 times, And then I took these and replicated them another 10 times. So one thing you can think about is just think of it as counting, but counting by grouping in such a way that the base, it's based on this base. That's how you're grouping the objects. And this just tells you how many times you're advancing through this grouping process. But again, you saw the way we're advancing is not by addition, but by multiplication. That's how we're grouping things or counting things. Think of it as counting, but in a large scale.